All right, so 13.1 measures of central tendency. All right, measures of central tendency. So the first thing they talk about in this section is the mean, which is the average. So statistics, they call the average the mean. So they're the same thing. So if you look at your steps, you add all your data values up and then divide by the number of data values. So, just the average. So if I have a data set of 1, 2, 3, 4, 5, if I want to find the mean, I will add them all together, then divide by 5. I have 5 data values, so I divide by 5. So 15 divided by 5 would be 3. So the average, or in other words, the mean of that data set would be 3. All right. Next one is the median. You can think about middle or middle value. That's your median. So first step, a lot of people miss the first step on this one, so make sure you hold true to it. You want to list all of your data values from least to greatest. It's always your first step. If the number of data values is odd, you take the middle value. If the number of data values is even, take the mean of the two middle values. All right. So let's say if I had a data set that had 1, 2, 3, 4, 5, I have 5 data values. So that means I do have a middle value because that's an odd number. So I just pick the middle number, which is 3. That will be your median. Now, if I have a second data set, let's say 1 through 6, since it's an even number, I don't actually have a middle value. So I would take my 2 middle values, add them together and divide by 2, and that will give me the median. So in this case, it would be 3 plus 4, which is 7. Divide that by 2, and that'll be 3.5. That's your median. And notice 3.5 is in the middle of the data set, is in between 3 and 4. Splits your data in half. All right, any questions? Everybody all right? All right, for the mode, think about most or most frequent. This is the data value that appears the most frequently. It is possible to not have a mode, and it is possible to have more than one mode. Oh, somebody says something in chat. How's it going, sir? Good. How's it going? Good to see you. Or at least hear from you, right? All right. Bimodal is having 2 modes. Multimodal is having more than 2. right, everybody okay for me to scroll up? All right, so if I have the data set 1782357669147456789, your mode would be 7 because it shows up the most. All right, any problems, any problems? All right, so that's it for 13.1. Questions before we go to 13.2? All right, so 13.2 is measures of dispersion. And dispersion is the degree to which the data is spread out. Start off talking about the range. One way we can look at the dispersion or compare dispersion is looking at the range. That's going to be the largest data value minus the smallest data value. So if my data set, once again, is 1, 2, 3, 4, 5, to find the range, I will go take 5, which is the largest, subtract 1, which is the smallest. That'll give me 4. All right. So next thing to talk about is your standard deviation. It measures how far a data value is from the mean, or in other words, how far a data value is from the average. Variance is the standard deviation squared, and is another way to measure the spread of your data. All right. All right. So notation. Everybody good with variance before I scroll all the way up? All right, notation. When it comes to statistics, your population and your sample will have different symbols representing the same thing for them. But when you see certain symbols, you know you're dealing with a population versus seeing other symbols, you know you're dealing with the sample. And so you talk about the difference between sample and population. If you look at Norfolk State student body, the whole student body would be your population, and this classroom would be a sample of that population. So that's the difference between the two. So your data value X, that will always be the case. X will always represent your data value. Then here we have Greek letter mu. It kind of looks like a U, but it has an extended stem on the left. That's Greek letter mu. And that's our population mean, population average. This circle with the extended stem is the population standard deviation. That's lowercase sigma. I said stigma, lowercase sigma. Capital sigma, which a lot of you probably have seen, if you know more than for the Greeks. Capital sigma is represented with this. Epsilon. It's epsilon. Anyway, never mind. Think about something else. But capital sigma, and that's the summation that represents the addition of all of your values. So if you have sigma, and then another term that would be the addition of all of your values. Then here, like we said, the variance squared is the standard deviation squared is your variance, and then capital N is your population size.
Can you go back up a little bit, please?
How far you need?
Just a little bit more. Right here.
All right. So like I said, that's the notation for the population. Whether you're dealing with sample or population, X will always be your data value. But that's your population. We'll scroll up to see our sample symbols in a second. All right, can we scroll up a little? All right, so your sample mean is represented by X bar. And any value with the bar over or any variable with the bar over is that variable bar. So if you have Y bar, then that's how you would say that. All right. Lowercase s is your sample standard deviation. Then s squared is your sample variance. And then lowercase n is your sample size. All right. Any problems? Any problems?
Under the letter M, is that an O?
Under the letter M, are you talking about right here?
In notation? Yeah.
Not,
Like,
are you calling this M?
yeah. Is that
Okay.
like
So that's going to be Greek letter mu.
Okay.
Yeah, and so that is your lowercase sigma. So it's going to both of those are Greek. Both of them are Greek letters.
Okay.
Yeah. All right. We all good before I scroll up. All right. So I'm not going to hold you to the formula of calculating the standard deviation or the variance, but what I will hold you to is finding, still have my eraser on, finding the app, website, or calculator, something of that nature that will calculate the standard deviation and variance for you. So you need something reliable that can calculate it for you. One I always suggest that's pretty easy to use is easycalculation.com. I'll show you how to, just search in a second. Just want to make sure everybody have a chance to write this stuff down. But yeah, so you can go to the App Store. There are a bunch of free things that you can find and use, but that's on you to find something that's reliable and legitimate And like I said, I'll show you one in a second. But the formula can be a little involved, especially when you go over 20 data values. It's one of those things when you mess up one, then you mess up the whole thing. Mess up one calculation, then you mess up the whole calculation process. But once again, you guys aren't held, well, at least I'm not holding you guys to doing it by hand. All right. So let me just check it real quick. So let me show you. We'll go back to the notes in a second. So all I would do is Google standard deviation, easy calculation. And the first one that pop up is easycalculation.com, but you have other ones down here as well. You know, if you don't want to use this one, no big deal. Pay attention to the directions, enter all numbers separated by a comma. And so that was 2, 4, 7, 12, 15. 2, 4, 7, 12, 15. And there goes your standard deviation and variance. So notice here, this would be your sample, and then notice this one says population, standard deviation, population, variance. And that's it. So if you're doing more than typing data values in and hitting enter, then to me you're doing too much, because too many free things out there for you to just be able to do. And then if you don't want to do easycalculation.com, you can just do standard deviation calculator. You know, like I said, other things will pop up. There go the formula right there. You know, if you want to see the formula, but yeah. Questions on that? Any questions? And make sure you pay attention in the directions if you're dealing with a sample versus a population. Normally, short data sets like this would be a sample. You know, a population, you would think large, you know, a large amount. Sample would be something small like this. All right. Questions, concerns, comments, anything, anybody?
Can you re-explain it, please?
Re-explain what? Get a little more. Say again?
The problem, like to find the standard deviance and
Go to a standard deviation calculator and type those values in.
okay.
Yeah, that's all I did. I didn't do anything, not by hand, you know, just Google standard deviation calculator, type in those data values, and then get the standard deviation from it. Yeah. That's all I did. And so what I was saying is that you don't necessarily have to use the website that I use. You could use a calculator that you may have, or you can use an app, you know. But whatever you can use something free. I'm not trying to get you guys to spend any more money. There's a bunch of free stuff out there that you can use. And all I'm saying is just type in those data values and make sure they produce these two numbers. And then I also said that easycalculation.com is one that I know works. So, all right. Questions. Everybody good? Everybody straight? So that's 13.1, 13.2. And when that's it for today, I mean, we don't have to do more. 2 sections is good enough. Just so happened that both of them were light. So, like I said, there's no rush. We got a whole month to get the rest of our work done. So questions, concerns, or comments before we close out today? Anybody have any questions on anything? Before I let you go.
No, sir.
All right. Thank you, sir. Thank you. All right. Well, if y'all are good, I'm good. Check this stuff out. Try it out. If you have any questions, make sure you bring them to class or shoot an email to me. And then we'll go from there. Other than that, you guys have a good one.
Have a good evening, sir.
Thanks. You do the same.
All right, big bro.
All right. Take it easy.